Hello everyone. So in this particular video, we will start with basically a discussion on what are the basic maths concept that you need for machine learning or deep learning or data science, whatever that is. So for all this entire field, what are the concepts of mathematics that you need to cover in order to let's say achieve success in this field? Okay, so the first thing I believe is going to be statistics and probability. So this I think is the most important out of all the concepts in mathematics. This concept, this chapter is the most important in order to do really good in machine learning and deep learning. So basically, what are the things that you need to cover? First is your normal statistics that you learn, okay, in your high school. So mean, median, mode, all these things. So this is not an exhaustive list. There are other things as well that you need to cover, but your basic statistics needs to be clear. After that, you should have in your statistics class, your concept of regression should be clear, because we are going to use it in linear regression and logistic regression. Okay, so this concept of regression is very important there. After that, you also need to have some good understanding of correlation. So what is correlation matrix and what does correlation actually mean? Okay, so all these things are very important. So for example, you will be using it in scatter matrix in let's say in pandas. Okay, there's something like scatter matrix which basically finds your correlation. Okay, there are also, let's say, some filter methods, where you have to remove certain features from your data set. So let's say your data set is it has certain columns, and you find out that two of the columns are very highly correlated, and let's say there is a y target column here, and let's say some column is it almost has no correlation with this. So basically what I want to say is that if there is a when we are dealing with these kind of data sets, you need to understand correlation, and for that the concept of correlation needs to be strong. Then obviously your general probability, because this is going to be very important. General probability means what is the probability of event. So favorable outcome divided by all outcome, that is what I'm talking about, probability of an event. So that should be very clear. After that, your probability distributions, where you have your normal distribution and uniform distribution, and there are other types of distributions. At least these two should be very clear, because we are going to use them extensively in this particular your chapter. In general probability, but let's say even in statistics, there is one more concept of maximum likelihood estimation. Okay, so this is not generally taught in I was not taught, I had to learn it from outside, but this is something that you need for your logistic regression, linear regression, and entire neural network stuff itself. Okay, so this is very important. This should be clear. Then there is conditional probability. Again, you will need it in a lot of places. Okay, especially in some type of let's say VAE, variational autoencoder, and all those things. When you're deriving their loss functions and all that, you will need probability, conditional probability. Lastly, Bayes rule, obviously. So Bayes rule you will be needing in let's say your naive Bayes classifier. Okay, so Bayes rule is important, but after that there is not much needed. But still, there is also, you might also need it in other places, in, let's say, in generative AI, if you're doing it. Okay, especially, there are places where advanced concepts like Bayes rule and all those are used. Okay, so this part needs to be clear, your statistics and probability. After that, what you need to do is linear algebra. Okay, so linear algebra is also very important. In that, now linear algebra is huge. Okay, but in that you just need to concentrate on three things. You need to first concentrate on basics of matrix calculation. Okay, so you need to understand how to multiply two matrices. Okay, what if, let's say, m cross n is multiplied by n cross p, then what will be the final dimension, which is m cross p. Okay, so all these things basically you need to understand. You need to understand what is transpose, what is inverse of a matrix. So these are the things that will be very important. So inverse is very important, transpose is important. There's so many times where, like for example, in a convolution, in CNN. Okay, so basically you do a convolution operation over there, but you take a transpose of the weight matrix. So there are other things, so you need to know all these things. Okay, inverse is also sometimes important. After that, in linear algebra, you also should know about eigenvalues and eigenvectors, because you need to do something like PCA, which is used for dimensionality reduction, and same for LDA. So this is also very, very important. And the most important of all, linear transformations that you have to do in case of your neural networks. Okay, so this is also very, very important, because neural network is based on linear transformations. So you can see over here, this is a neural network, and these are the neurons, and these are the connections over here. Basically, you can say that here you give certain input and you get output. This I'm not talking about the activation functions that you use at over here. I'm just talking about this particular. This is a matrix, right? What does a matrix do to a vector? It transforms from one space to another. So we need to understand linear transformations clearly. So focus on this part, because it's going to be the basis of neural networks. Okay, now having done that, let's move to the next part. So after that, after linear algebra, what should be clear is calculus. Okay, so you need differential calculus. So you need what to say, basic differentiation and partial derivatives as well. So you need both of them. Where do you need it? You need it for back propagation. Okay, so back propagation is used to train a neural network, so you will need it there. After that, you need to know the basic what is f of x, how it is used, and all of those things. This will be used for activation functions. Let's say sigmoid. So let's say sigmoid is there, so that is 1 by 1 plus e to the power minus x. Okay, so this is actually a function in x. So what is function, how do you take the derivative of this, and all that differentiation is required there as well. Thirdly, you need maxima and minima. This is for your loss function. So whenever, let's say, you say you have to minimize the loss. Okay, so what does minimization mean, and how can we use calculus to do that? That is something you will have to that is something you'll have to uh, read. Okay, lastly, you also need chain rule and product rule. This is again for back propagation, because back propagation is nothing but chain rule. Okay, product rule is basically for differentiating when two functions are multiplied. So these things are very, very important. Okay, now this is not, again, as I said, this is not an exhaustive list. There are other things as well, but these things, if you know, you are already up for a good start. Now the question that I want to know from you, whether you want me to cover all this or not, because there are already a lot of videos. Yes, they are not perfectly geared for machine learning and stuff, but there are some amazing playlists. So I just wanted to know whether you want me to cover all these things or not. Okay, so if you like the video, please like and subscribe. Thank you very much, and bye.